Good morning. My name is Marina Kolebanova. I'm a student of Samara University, and today I'd like to talk about modeling the propagation of elliptic Laguerre-Gaussian beams. The purpose of this work is to numerically study the propagation of elliptic classical Laguerre-Gaussian beams and 3-index elliptic LG beams. My study is relevant nowadays because LG modes are successfully used in applications such as optical capture and manipulation of microparticles, sharp focusing, laser structuring, etc. The significant demand for LG vortex modes in various applications motivates researchers to consider other types of vortex beam, including modified versions of LG modes. To perform the numerical study, the program in Python was made that modeled the propagation of LG beams using the Fresnel transform and the Fourier transform. In my presentation, I will focus on 3 major issues: theoretical basics, results of the modeling, and conclusion. Let's begin with theoretical basics. LG modes are paraxial light fields with a radially symmetric intensity form, modes of resonators, optical waveguides with a parabolic refractive index, and also retain their structure up to a scale during propagating in free space and passing through lenses. In this paper, we study the propagation of an elliptic LG beam, which can no longer be considered a mode. Such beams with a varying degrees of ellipticity can be used to produce laser elliptic beams with uniform intensity over the beam cross-section. The LG modes can be described by 2 indices, the radial index n and the azimuthal index m, which is also associated with the vortex phase structure and included in the phase multiplier. The LG mode is a vortex optical beam and has an integer orbital angular momentum, which is determined by the order of the optical vortex, in other words, the azimuthal index m of the mode. A distinctive feature of the vortex optical beam is the presence of 5 singular points, in which the phase is not defined and the amplitude is 0. We come now to the description of propagation of LG modes. It's known that using a lens in optics the Fourier transform is performed. In the coherent light, the distribution of the light amplitude in the rear focal plane of the lens can be represented as a 2-dimensional complex Fourier transform of the distribution function of the light amplitude in the front focal plane of the lens. This transformation is closely related to the Fresnel transform, which allows you to model the propagation of the light over certain specified distances and is given by the expression for. Now we will look at the results of the modeling. In the figure 1 and 2, we can see the intensity and the phase distribution of the elliptic LG beam after passing through a lens. As can be seen from the results, when propagated through the lens, the elliptic LG beam forms a diffraction pattern that is rotated by 19 degrees. The parameter n+1 characterizes the number of rings, and the ellipticity decreases with increasing alpha. In the figure 3 and 4, we can see the phase and the intensity distribution of the elliptic LG beam after propagating in the free space. The simulation results showed that during propagation, the elliptic LG beam is structurally modified. The amplitude clearly shows the splitting of the m-order vortex phase singularity into m first-order optical vortices along the line at an angle. The angle of inclination depends on the parameter m. At m more than 0, the angle is plus 45 degrees. At m less than 0, it is minus 45 degrees. Near the actual point in the beam cross-section, m intensity is 0 occurs. In the figure 5 and 6, we can see the intensity and the phase distribution of the 3-index elliptic LG beam after passing in the free space. It can be seen that the 3-index elliptic LG beam during propagation is structurally modified similar to the elliptic LG beam. To sum up, I'd like to say that in the present work we have studied the standard elliptic and 3-index elliptic LG beams. We have modeled the propagation of these beams in free space over various distances using the Fresnel transform and the passage through the lens using the Fourier transform. Modeling the propagation of elliptic LG beams and 3-index elliptic LG beams showed that the presence of ellipticity leads to the splitting of the initial high-order vortex singularity into first-order optical vortices. Thank you for your attention.